Good morning, everyone, and thank you so much for joining us today. I do appreciate it. We are going to be taking a look at adding and subtracting fractions. So adding and subtracting fractions. Now, the problems that we're going to be looking at today are ones that have denominators that are the same. Later on, we'll be diving into ones where the denominators are different. So our first problem, and we're going to work all these through the lens of problem solving in order to make sure that you have a good connection of what exactly it means when you're doing things like this. So the first problem says Shelley has 2/6 of an apple pie and 3/6 of a pumpkin pie. How much pie does she have? So the first piece of information I need to pull out is going to be the 2/6 of an apple pie and the 3/6 of a pumpkin pie. Now, I prefer to use a number line to show these because you can actually combine a fraction model and a number line to make this easier. So I know that my number line is going to be broken down into pieces of 6. And so I have my number line. I have my fraction bar on top that's kind of connected to it. I'm going to start with 0. I have nothing on one end and I have one whole on the other. Now, based on my fractions, each of my fraction bars needs to have 6 pieces. So the first thing I'm going to do is I'm going to split this into 3 pieces to make it easier on myself, because 3 is relatively easy to make. But then I know that 3 times 2 is 6. So if I break each of these sections into 2 more pieces, I'm going to have the 6 pieces I need. So I can label this place as 1/6, 2/6, 3/6, 4/6, and 5/6. And then 1 whole would equal 6 out of 6, and it would also equal 6 over 1. So that is a way that you can compare 1 whole is also 6 pieces out of 6 pieces, or 6 pieces out of 1, or 6 over, I'm sorry. Ignore me. I apologize. The 6's got running through my head, or 1 over 1. Please ignore my befuddled brain this morning. So now I need to start filling in my pieces of apple pie and my pieces of pumpkin pie. So I have 2 pieces out of 6 that's an apple pie. So I'm actually going to come in, I'm going to outline these 2 pieces, and I'm going to kind of shade them in a bit. And I'm going to label them as AP for apple pie. And then I have 3 pieces out of 6 that are pumpkin pie. So this is 1, 2, 3 pieces that I'm going to shade in that are pumpkin pie. So how much pie does she have? Well, with the apple pie added to the pumpkin pie, I can see according to my number line that it's 5 pieces out of 6 total, which is my final answer. Okay. Excuse me, I have a sneeze coming. Now you can also look at this without the models, but the models is how they're going to expect you to be able to solve it. They're going to give you the models. You are going to have to break it down, or they'll give you the problem and they'll want you to create the models. You can also say 2/6 plus 3/6. And in this case, you have the same number of pieces. So this sixth is the same size as this piece, 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 the same size as this piece. So that means that if the denominators of our fractions are the same, then all we have to do is add the numbers on top. So this is going to become 2 plus 3 over 6, and 2 plus 3 is 5. And our denominator stays the same. So if the denominators are the same, you just have to add the numerators together and you have your answer. All right, so let's look at our next one. Kyle bought a pizza and ate some, leaving 7/9 of the pizza in the box for later. The next day, he ate 4/9 of the remaining pizza. How much pizza is left for dinner? Now, in this case, I'm starting with a whole pizza. Some is getting eaten, leaving a part, and the next day, more is getting eaten. So while this one was addition, we're now looking at subtraction. Either way, our process is still going to look very, very similar. I'm going to start by creating my number line. And I'm going to specifically focus on, so it says he bought a pizza and ate some, leaving 7/9 of the pizza in the box for later. Okay. And then the next day, he ate 4/9 of the pizza that was remaining. So how much pizza is left over for dinner? All right. So we don't know how much he ate originally, but we do know that 7/9 of the pizza was what was left over after he bought it and ate some the first time. So I'm going to start with 0. I have my 1 whole at the end. And in this case, this is going to equal 9 pieces out of 9, which is also going to equal 1 out of 1. And if you compared them, 1 whole is equal to 9 out of 9. And 9/9 is equal to 1 over 1. So I need to break this fraction bar and my number line into 9 pieces. So just like I did before, since I'm working with a multiple of 3, I broke it into 3 parts, and I know that 3 groups times 3 in each group equals 9. So I just need to break up each individual piece or section of the fraction bar into 3 more, and now I have 9 pieces. So 1/9 is my first piece, 2/9, 3/9, 4/9, 5/9, 6/9, 7/9, 8/9, and then of course 9/9 is equal to 1 whole. All right, so he started with 7/9. And so I'm going to take my trusty little markers, and I'm actually going to use a bigger one to make this easier. He started with 7/9 of the pizza the day after he bought it. And the next day he ate 4/9 of the remaining pizza. So that means that out of the original 9, he had 7 pieces left. He ate 4 more. So that means that I need to cross out 4 of these pieces. So there's 1, 2, 3, 4. So that means that we have a remaining 3/9 of the pizza for dinner that night. Okay. If you look at it using what's considered kind of standard algorithm, you started with 7/9. You're taking away 4/9. The denominators are the same, so all you need to do is subtract the numerator. 7 minus 4 over 9. 7 minus 4 is 3. The denominator stays the same. 3/9. All right. I am not expecting you to work it this way. I am expecting you to work it with a model and to be able to draw it like this. So let's take a look at our next examples. All right. So Angelica has 4/5 feet of wood to build a shelf with. If she uses 3/5 feet of wood per shelf, how much will she have left? So I want you to take a couple of seconds and I want you to think to yourself, do you think that this operation is going to require us to add or subtract? All right, so I know that she's starting with 4/5 feet of wood and she's using 3/5. So I'm taking that away, which means that I'm going to be subtracting in this problem. And just like I did with the others, she has 4/5 feet of wood. She uses 3/5 feet of wood per shelf. How much will she have left? I'm going to start by drawing my number line / fraction bar. I'm going to start with 0 and go to 1. My denominator is 5, which means that this needs to be split into 5 pieces. Now, for fifths, there's really not an easy way to draw it. You just kind of have to do your best and guess. So 1, 2, 3, 4, and 5. The most important thing when you are drawing fraction bars is that no matter what, the number of pieces needs to match. Hand drawing fraction bars, you're never going to get them even or perfect, and that's okay. But especially once we get into dealing with fractions that the denominator is different, you need to focus more on the number of pieces, not necessarily trying to get them perfect and the exact same size. So she's starting with 4/5 feet of wood. I need to label the rest of my number line. I have 1/5, 2/5, 3/5, and 4/5. I can fill in that she has 4/5 feet of wood. I do recommend when you're doing these fraction problems that you are using color to distinguish your work. That way it's very, very clear what you're doing. Otherwise you can confuse yourself very quickly. She uses 3/5 feet of wood. So that means 3 pieces. If the whole thing is split into 5, she uses 3 of those pieces. So I'm going to mark out 1, 2, 3/5 feet of wood. So this is what she used. And so this means that we have completed our subtraction. Now we need to determine what is remaining. And in this case, we have 1/5 feet of wood left over. So if you wanted to take a look at this using the standard algorithm, you're starting with 4/5 feet of wood. You're taking away 3/5. And remember, if our denominators are the same, we just have to add or subtract the numerator. So I'm going to subtract 4 minus 3, and that's going to be over 5. 4 minus 3 is 1. My denominator stays the same. Okay, so she had 1/5 feet of wood left. All right, our next problem. A painter is trying to create the perfect shade of color A. They use 5/10 of a tube of color B and 3/10 of a tube of color C to make color A. Okay, so I want to make sure I'm understanding this. So I'm going to kind of come down here and I'm thinking, okay, so color A is what they're wanting to make, and they're using color B added to color C to make color A. Okay, I understand this now. What fraction of a tube of paint was used to create color A? Okay, I want you to take a couple of seconds and think to yourself, what operation are we going to be doing, adding or subtracting? If you said subtracting, or I'm sorry, if you said adding, you are correct. So I'm going to start by drawing my number line / fraction model. Okay, I have 0 on one end, I have 1 whole on the other. And if I look at my fractions, both of them are broken up into tenths, which means there are 10 pieces. So now it's going to get a little complicated because drawing 10 can be a little hard. I find that if I split a fraction bar in half, I now have 2 pieces. And I know that 2 times 5 is 10. So if I break each part of this bar into 5 pieces, I'll have 10 in all. So 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. All right. So I have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, and 9/10. Okay. So I am trying to imagine what color they may be coming up with. In my brain, I know that blue and red make purple. So I'm going to focus on using those 2 colors. So I'm going to say that color A is going to be purple. And that means that color B is going to be red, and color C is going to be blue. Okay. And this just helps me get a good visual in my mind. So color B, they use 5/10 of a tube of color B. So there's 1/10, 2/10, 3/10, 4/10, 5/10. So I can just come in here and shade those. And then of color C, they used 3/10 of a tube. So there's 1, 2, 3/10. And shade that in. And I know that put together, these 2 colors are creating color A. So this means that if I've added these 2 together, that means that I've got 8/10 of a tube of paint that was used to create color A. And I know this because 5/10 plus 3/10 is 8/10, and I can even write it this way. 5 out of 10 plus 3 out of 10. Our denominators are the same, so that means we just need to add the numerator. 5 plus 3. So that's going to tell me 5 plus 3 is 8, and my denominator stays the same. 8/10 of a tube was used to create color A. All right, well, thank you guys so much for watching. I hope that this was useful and helpful. I will be taking pictures of these and uploading them into the notes section on Canvas for Unit 3, and we'll be working more in class. Have a great day, guys.